I'm now going to talk about testing of gases. Let's see how various gases are tested chemically. How to confirm whether a particular gas is chlorine or bromine or HCl, testing of gases. Number 1, testing of ammonia. Ammonia can be tested with a glass rod dipped in dilute HCl. It gives dense white fumes at the mouth of the test tube. Next, you get a brown precipitate with Nessler's reagent. And another most important, moist red litmus turns blue. These are the 3 important tests for ammonia. Ammonia gas gives dense white fumes with a glass rod dipped in HCl. Another one is ammonia gas, when bubbled into Nessler's reagent, forms a brown precipitate, and ammonia gas turns moist red litmus paper blue. So these are tests for ammonia. Next, carbon dioxide. With carbon dioxide, lime water turns milky. The reaction which is involved is CaOH taken twice plus CO2 gives CaCO3, which appears as milkiness. But care is to be taken that you should not pass excess of carbon dioxide, then calcium carbonate becomes soluble bicarbonate. So limited amount of carbon dioxide should be passed so that you get a milkiness due to CaCO3 formation. It turns moist blue litmus red. It turns moist blue litmus red. So these are 2 important tests for carbon dioxide. It turns lime water milky, and the milkiness is due to formation of CaCO3, and blue litmus, moist blue litmus turns red due to carbon dioxide. Number 3 in the list is HCl, testing of HCl gas. A, it turns moist blue litmus red. This is one test for HCl. Apart from this, it produces dense white fumes with a glass rod dipped in ammonia. These are 2 important tests for HCl. It turns moist blue litmus red, and it gives dense white fumes with glass rod dipped in ammonia. This is again due to formation of NH4Cl. This is the reaction involved. NH3 plus HCl gives NH4Cl. This appears as dense white fumes. Number 4. Number 4 is SO2. A, turns acidified dichromate green. It changes the color of acidified dichromate. The reaction involved is Cr2O7 2 minus plus SO2 plus H plus, you get SO4 2 minus and Cr3 plus. Of course, you get water also. So the color of this is green, this is orange. Fine. Apart from this, it turns lime water milky, and milkiness is due to formation of calcium sulfite. Decolorizes acidified KMnO4. It decolorizes acidified KMnO4. So these are few important tests for sulfur dioxide. Sulfur dioxide changes acidified dichromate green. It gives milkiness with lime water. This is common for carbon dioxide and sulfur dioxide, and then it decolorizes acidified KMnO4. In the reaction A and C, sulfur dioxide is said to be acting as a reducing agent. The reaction involved here is MnO4 minus, SO2, H plus, you get Mn2 plus, SO4 2 minus, water. This has very intense color due to ligand to metal charge transfer phenomena. The color of this is very, very light. So it appears as if the solution got decolorized totally. Number 5 is chlorine. Let's see how chlorine is tested. A, it's a greenish yellow gas. B, it bleaches moist litmus. See, this bleaching is due to oxidation. Chlorine, when in moisture, it produces HOCl, and the nascent oxygen released by HOCl is responsible for bleaching of litmus. Whether you hold moist blue litmus or moist red litmus at the mouth of the test tube where chlorine is being produced, then the litmus will be decolorized. It turns starch iodide paper blue. Turns starch iodide paper blue. Look at the reaction. I minus, chlorine, moisture. I minus will get oxidized to I2, Cl minus. Right. Now, this will give blue color complex with starch. Iodine forms a blue colored complex, bright blue colored complex with amylose component of starch. Number 6, bromine. Testing of bromine. A, reddish brown fumes. B, slowly bleaches litmus. C, turns starch iodide paper blue. Here also remember, bromine is a stronger oxidizing agent than iodine, so it oxidizes iodide to iodine. Iodide plus bromine gives bromide plus iodine. It is the iodine which is formed in the reaction is responsible for turning starch paper blue. It turns starch paper brown. Bromine turns starch paper. There's a difference between starch iodide paper and starch paper. Starch paper means starch paper as such is taken and it forms a brown colored complex with bromine, but starch iodide paper is a starch paper which is dipped in Ki. So these are tests for chlorine and bromine. Testing of iodine. Testing of iodine. Iodine appears as violet fumes. It turns starch paper blue. The last one, number 8, testing of H2S gas. Turns lead acetate paper black. It turns lead acetate paper black. The reaction which takes place is PbOAc taken twice plus H2S. It gives a black colored substance PbS. It blackens silver foil. Ag plus H2S, it forms Ag2S, which is black. This is formed on the surface of silver foil. Gives purple color with sodium nitroprusside. Na2FeCN5NO plus H2S. You get FeCN5NOS 4 minus. This is a purple colored complex. So these are few important tests for H2S. H2S turns lead acetate paper black due to formation of lead sulfide. It gives black colored Ag2S when silver foil is introduced in a jar containing H2S, and it gives purple color. It gives purple color with sodium nitroprusside. Well, with this we have come to an end of testing of gases. We have done testing of 8 different gases: chlorine, bromine, iodine, HCl, H2S, ammonia gas, SO2 gas. We have discussed how these are tested, what are the various reactions involved in testing of these gases. We will have to now learn about cation analysis. We have so far done preliminary test, anion analysis, and we have seen how various gases are tested.